Assalamualaikum warahmatullahi wabarakatuh. Hi everyone, how are you today? Hopefully we are always in good condition. Who I respect, Mr. Professor Dr. Sutarto Hadi MSc MSc, Miss Kamaliah MPD, and Miss Ramita Norobaiti MPD as a lecturer in Mathematics English courses. Let me introduce myself. My name is Tiara Paramita. My ID number is 211-011-81-0008 from Group 9 in Mathematics English courses. Today, I will explain about the last second meeting. The last second meeting about statistics and counting. We have 3 points: is vocabulary, video, and 4 example. Okay, the first material is vocabulary. Vocabulary 1 is cube. Cube in Indonesian is kubus. A cube is a geometric figure bounded by a 6 square sides. The example is, from picture here, we have a cube A, B, C, D, E, F, G, H. We have information. There are 12 edges in the cube. The edges of a cube are the same length. AB ribs parallel to rib CD, EF, and HG or GH. The ribs BC parallel to the ribs AD, EH, and FG. Next is cuboid. Cuboid in Indonesian is balok. A beam is a three-dimensional geometric shape formed by 3 pairs of squares or rectangles with at least 1 pair of different sides. The example is, from picture here, we have information. The block is composite of 3 pairs of equal sides, or total 6 sides. All is 6 sides. 8 sides is a quadrilateral, EA, a square or a rectangle. Must have at least 1 pair of sides with a different shape. Next is pyramid. Pyramid in Indonesian or piramida or limas. A pyramid is defined as a three-dimensional structure that includes polygon as its base. The example is here and here. Here is pyramid and pyramid. Side here is perimeter. From here to here is height. And from here to here is chart length. Next is prism. Prism in Indonesian is prisma. In geometry, a prism is a three-dimensional figure bounded by an identical base and light in the form of an angle and vertical sides in the form of a square or rectangle. The example is, here is square prism, here is triangular prism, here is trapezoid prism, here is rhombus prism, here is regular pentagonal prism, here is regular hexagonal prism, here is rectangular prism. Okay, the next vocabulary is cylinder. Cylinder in Indonesian is cylinder. A cylinder is one of the basic 3D shapes in geometry that has 2 circular bases parallel at a given distance. Example cylinder is here. Here is H. And here, from here, is R. Here to here is diameter. Diameter is 2 times R. Okay, next is spear. Spear in Indonesian is bola. The ball is one of the curved side shapes which is composed of an infinite number of circles centered at one point, namely the center point of the ball. Example is uh, from picture here. Picture here is sphere. This this spherical shape has one side. The sides of the ball are a collection of points that the equidistant from the center of the ball. The sides of the ball may be referred to as the surface of the ball or the spherical blanket. The ball chamber structure has no ribs. In the picture above, the part named with R is the radius of the ball. The radius of the ball connects the center point of the ball with a point on the surface of the ball. Next is cone. Cone or Indonesian is kerucut. In geometry, a cone or conus is a special pyramid having a circular base. The example is picture here is cone. Side here is blanket. And here is topper. From here to here is T. Here to here is R. Here to here is diameter. Here is base. Sphere here is base. I'm sorry. Circle here is base. Next is edge. Edge in Indonesian is tepi. In geometry, an edge is a specific type of line segment that connects two verticals in a higher dimensional polygon, polyhedron, or polytope. The example is picture here. Here is edge. Here, in here. Next is surface area. In Indonesian, surface area is luas permukaan. The shapes occupied by a two-dimensional flat surface is called area. It is measured in square units. 10. Vocabulary 10 is vertex, or in Indonesian is puncak or simple. In geometry, a vertex is a point where two or more curves, lines, or edges meet. The example is here is vertex, so common point of two rise, and here is vertex because common point of two line segment A, B, and AC here. Okay, next material is video. Combination formula, probability, and combinatorics. The question is, we have six people, person A, B, C, D, E, F. If we put them into four chairs, how many permutations are there of putting these six people into four chairs? The solution is there are four chairs and six people. So, 6, 5, 4, and 3. Or 6 times 5 times 4 times 3 equals to 360. That is number of permutation. So we call word as formula permutation is n permutation r equals to n factorial divided by n minus r factorial. So n is 6. 6 people is in, and r is 4 chairs. So we substituting in formula permutation. 6 factorial divided by 6 minus 4 factorial equals to 6 times 5 times 4 times 3 times 2 factorial divided by 2 factorial. 2 factorial divided by 2 factorial equals to 1. So 6 times 5 times 4 times 3 equals to 360. So the permutation of 6 people into 4 chairs are 360 wise. From formula permutation, P is the number of permutation. N is total number of objects is here, people. And R is the number of causing object from the set here, 4 times. Next is how many wise are they choose for people from a pool of 6. If we didn't care about was sitting in which chairs, we could use the combination formula. N combination R equals to N factorial divided by R factorial times N minus R factorial. When C is the number of combination, N is the total number of objects in the set, and R is the number of choosing objects from the set. So, N from question here is 6, and R from question 6 is 4. So, 6 combination 4 or combination 6 of 4 equals to 6 factorial divided by 4 factorials times 6 minus 4 factorial equals to 6 times 5 times 4 factorial divided by 4 factorial times 2 factorial equals to 2 factorial, I'm sorry, 4 factorial divided by 4 factorial is 1. So, 6 times 5 divided by 2 factorial. 2 factorial is 2 times 1. So, 6 times 5 equals to 30. And 30 divided by 2 equals to 15. So, the combination of 6 people into 4 chairs are 15 wise. Okay, the next material is example. The first example is example 7. The question is, student ID numbers all have 8 characters. The first 2 characters are different letter choose from the letter A to F. The remaining 6 actors are digits from 1 to 9, which can be repeated. How many different ID numbers are possible to create? The solution is, the situation is the same as filling a slot. The first slot is filled with a letter from a set of 6, while the second is filled with a letter from a set of 5 signs. We cannot repeat the letter we already used. All the rest are filled with a number from a set of 9 each. Signs we can repeat digits. The model is here is different letter chosen from the letter A to F, stroke F. So 6. So this is one from 6. So here is 5. 6 minus 1 is 5. Here is 3, 4, 5, 6, 7, 8 is digit from 1 to 9, which can be repeated. So this is 9, 9, 9, 9, 9, 9, or 6 times 5 times 9 times 9 times 9 times 9 times 9 times 9, or 9 the power of 6 equals to 15 million 943,260. So the final answer is 15,643,230. Next is example 8. The question is, How many Ys can 4 out of 7 students be seated in a row of 4 chairs? How many Ys can all 7 be seated in a row of 7 chairs? The solution is, for the first situation, we have permutation 7 of 4. So, 7 factorial divided by 7 minus 4 factorial equals to 3 factorial equals to 7 times 6 times 5 times 4 times 3 factorial divided by 3 factorial. 3 factorial divided 3 factorial equals to 1. So 7 times 6 times 4 times 5 equals to 840. Next, for the second situation, we have permutation 7 of 7. So 7 factorial divided by 7 minus 7 factorial equals to 0 factorial. 0 factorial is 1, so 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 and times 1 equals to 9040. The next example is example 9. The question is, Mr. Fredericks wants to have a mock election in his social studies class. Students have to elect 4 people to serve as class officer. If 9 students were nominated, how many possible different groups of 4 could the class elect? The solution is, if the problem asked for specific officer position, we would be counting permutation. Since if there is not, we will find the number of combination. We use combination 9 of 4 equals to permutation 9 of 4 divided by 4 factorial. Permutation 9 of 4 equals to 9 times 8 times 7 times 6 divided by 4 factorial is 4 times 3 times 2 times 1. So equals to 216. The last example is example 10. The question is, how many different diagonal can be drawn in a regular octagon or an eight-sided figure with equal sides? I'm sorry. The solution is um, um, for question here, we have solution is combination. We can draw a illustration. Set here is A B C D E F H I G H. The solution is combination 8 of 2 equals to permutation 8 of 2 divided by 2 factorial. Permutation 8 of 2 equals to 8 times 7 divided by 2 factorial is 2 equals to 28. However, egg of this pair are not diagonals but but sides of the octagon. Therefore, the answer is 28 minus 8 equals to 20. Okay, that is my presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.